Hi, everyone. Thank you for choosing our serve presentation to watch. My name is Lucas Gleasman.
And I'm Daniel Guthrie, and we're with Gleasman and Guthrie Engineering, and our serve presentation is over the Lewis and Clark County Public Works Administrative Parking Lot that we are going to upgrade.
So, a quick project description of what we're trying to accomplish here is that we're going to excavate and replace an existing gravel parking lot. Our design is going to be a 3,900 square foot parking pad. And the biggest thing that the sponsor asked for this project is install some ADA approved features so that the exact existing lot is now up to code.
This is a bird's eye view from Google Earth of the existing site right now, and it's about halfway down Benton past the train tracks at 3402 Cooney Drive, Helena, Montana. If you'll notice that green arrow on our picture right there is the Lewis and Clark County Public Works Administrative Building, and then it's actually pointing to the spot where we're going to pave our 30 by 130 asphalt pad.
So, the existing conditions that the lot is now at is it's a washed gravel parking lot, and it's in extremely poor condition just because of the Montana weather conditions and the Lewis and Clark Public Works. They have a lot of heavy traffic or heavy vehicles that are driving through the area quite a bit. So, the parking lot's just in very poor shape, and right now, again, like I said earlier, there just isn't any ADA features on the site, so that's what we're going to design for to fix. So the design criteria and constraints that we're going to have to meet, starting with the criteria is we're going to have to abide by the Montana Department of Transportation's Americans with Disabilities Act requirements, the engineering design standards for the city of Helena, the Lewis and Clark Public Works Manual, and the public right-of-way guidelines. So when we first kind of attacked this design problem, we had three different design alternatives that we thought of. We first thought of asphalt pavement, which would require 49 tons of asphalt concrete. Then our second alternative was concrete pavement, which would require 3,900 square feet of 6-inch concrete. And then our third alternative would be washed gravel, which would just be replacing what's already there. And because, again, like I said, it just doesn't hold up to the weather conditions and the heavy vehicle traffic that the site sees, as well as there isn't any ADA structures in place. So we immediately ruled out alternative 3 in our process. So last semester we put together a quick preliminary cost analysis, and we just compared the asphalt pavement to concrete pavement. And how we decided the unit cost for our materials was that there was a similar construction project that took place here in Helena. It was called the Front Street Improvement Project. And so what I did is I just took an average of all three of the contractors that bidded on the project, and I just took an average of that, and that became our unit price for the similar materials that we would be using during our project. And just, again, based off the asphalt and concrete pavement, just looking at the total cost just for those alone, we saw that the asphalt pavement was significantly much cheaper than the concrete pavement.
Now, before we pull the trigger on any material that we're going to use for a project, the first thing that we want to do is we want to do a sustainability assessment. And there's going to be a few charts and graphs on the next couple slides, but they're pretty simple to understand. If you look at over here, we list an alternative A and then an alternative B. Our alternative A is going to be our asphalt pad, and alternative B is a concrete pad. And what this is going to do is it's just going to ask a series of questions that relate to the sustainability of the product in use. And if the answer to the question is yes, we're going to put 1 in that square, and if it's no, we're going to put 0. And then we're just going to tally up all of our yeses because the answer to the question should be yes, and that's going to make it more sustainable. So for instance, if we look at under Table 1, Sustainability Metric A, does the design utilize recycled or reclaimed materials? And alternative A does. As engineers, you need to know that asphalt is one of the more recyclable materials that you can use for a project. And so immediately going into this, we knew that asphalt was going to be the more sustainable option. Still, we filled out the entire sustainability assessment. Table 1 relates to the materials production and acquisition. Table 2 relates to construction. Tables 3 relates to the sustainability metrics. Table 4 represents the demolition aspect. And then all that we're going to do is, you'll see in Table 5, we summarize all of the tables, and then we add all those up. And Alternative A has 26 sustainability points, while Alternative B only has 22, which means not only is asphalt more cost-effective, but it's also much more sustainable, which leads us to know that for the project, the preferred alternative is definitely going to be an asphalt pavement. Before we could start doing our detailed drawings, we needed to gather some data, and the two biggest ones were surveying the existing lot to figure out what the grade is, the slope of the site, and then also we needed to collect soil samples to determine what it was that we were going to be excavating. First, the surveying was fairly straightforward. We surveyed the area and then a little bit past the area to see where it was that our runoff would run to. And we found that all the runoff could be basically contained on site, so there wasn't going to be any retention ponds that we needed to establish while building, which our sponsor had told us that he didn't want us doing. He didn't want us having any retention ponds just because of how flat the area was. And then we were able to collect a soil sample. However, we needed to collect it last semester, right around the middle of winter, and the ground was frozen, so our sponsor was able to haul an excavator out for us to fill a sample bag with some of the soil. And what you see here is us doing a sieve analysis of the soil, and the sieve number is corresponding to an opening of millimeters, and what you'll notice is that the sieve numbers get progressively bigger, but the millimeter openings get progressively smaller. And all that this analysis is showing us is what percent of the soil fits these openings, what percent is retained and what percent is passed. So you'll see in the next slide what we do is we use that percent retained on the number 10, 40, and 200 to determine exactly what soil type it was that we had. And we discovered that our soil actually fit under the excellent to good category, which is just a general rating of subgrade. Down here, it's excellent to good. And if you look at our next slide, what that means is for a traffic class, which is just the number of spaces fewer than 50 spots, which is what our site has, and a class of good, the California bearing ratio is around 9, which means that the aggregate base course, we're going to need about 4 inches of thickness there, and for the asphalt, we're going to need 3 inches for a total of 7 inches of excavation. And again, this would change depending on the quality of the soil and the number of spaces that we would have. But for this project, it was fairly simple.
So now that we know all of our excavation quantities and our material quantities, we ran a cost analysis of the asphalt pavement project. And again, like I stated earlier, I used the same unit price process from the Front Street improvement project here in Helena to get our unit prices for each of our materials. And so after we ran our cost analysis and hopefully included all the materials that will be needed on the project, we estimated that this project will cost around $21,000.
So this is the first detailed drawing that we did. What you'll notice is that the building is at the top of the drawing, not drawn to scale, and then the road is at the bottom of the drawing, also not drawn to scale. That's not a huge deal because we're not actually tying into the road. What you'll see is that we've got our 30-foot by 130-foot asphalt pad, and in it you're going to have 8 20 by 12 parking spots. And this is important to notice that it's 20 by 12 because most parking spots are actually a little bit narrower, sort of like 20 by 9, provided they're not ADA spots. But because most of the people on this site drive trucks because they work for the county, our sponsor requested that the spots are a little bit wider. So the number worked out pretty well that we could give them 20 by 12 foot parking spots, with the exception of one van accessible ADA spot, which is going to be 14.5 feet wide, and it's going to be right next to that ADA loading zone, set it off of the building. And then there was no real way to make all the spots besides that spot 20 by 12 and still not have any dead space on our pad, so we have one big spot as well right next to the ADA on the other side. It's not ADA exclusive. It's probably for the boss to park. It's the biggest spot on the lot that's not ADA accessible. Not only that, we also have a 5-foot sidewalk over the entire 130-foot length of our lot, and it slopes down a little bit toward the ADA accessible ramp, which is centered off of that ADA loading zone, and it's going to be 4 foot by 2 foot, and it's going to be textured so that the accessibility is a little bit friendlier for people in wheelchairs. And then the ADA loading zone itself is actually 5 feet wide. All of these stuff we got from the ADA and ProLab requirements.
So now we're going to be looking at the asphalt and concrete cross sections that will be constructed. So as I stated earlier, or as was stated earlier, we're going to need a 4-inch thick, 1.5-inch base course for both the concrete sidewalk as well as the asphalt parking lot. And then for our asphalt section, you can see as we spoke earlier, we're going to have a 3-inch thick asphalt pavement placed on top of our base course. And then looking at our concrete sidewalk section, we researched that most concrete sidewalks are about 4 inches thick, so we have drawn our cross section according to that. And then to the right of the drawing, we have our ramp leading down from the sidewalk down to the asphalt pavement parking lot. And again, this ramp is based off the MDT detailed drawings that are ADA accessible, and so that way our sidewalk will be up to code for the project. And then here we're also going to be placing a sign at the ADA accessible parking spot. So here these drawings just kind of are the quick overviews of how the sign should be placed in the concrete, as well as how far away from the sidewalk and how the sign itself should be mounted on the post. And then also during our design process, we have to consider the environmental and societal impacts. So during construction, there's always going to be a possibility of hazardous spills, whether it's gas or diesel from the equipment being used. So we need to have spill kits accessible on site during the construction process, that if that was to happen, we can clean that stuff up immediately. And then also there is underground utilities in the site location. So we will have to request a utility locate from the Montana 811, which what they do is you request a locate of the construction area, and what they do is they come in with some equipment and they can mark out where the utilities are, so that during construction the contractor is aware of where the underground utilities are located. And then also, because the construction will be taking place during the day, we will let the neighbors know that there will be noise of construction going on, just so they're well aware that it'll be pretty noisy throughout the day. And then some required permitting that needs to be done is that the contractor will be required to obtain a sidewalk and curb and drive approach permit through the city of Helena.
So in conclusion, we are creating a 30 by 130 foot asphalt pad that will serve as a parking lot for the Lewis and Clark County Administrative Building. We're going to excavate 7 total inches, and then the first 4 inches that we fill in will be a 1.5-inch base course, and then we'll add 3 more inches of an asphalt pad on top. It'll have a total of 10 parking spots, 8 being 20 by 12, and then 2 of them are going to be 14.5 by 20. And then it's going to come with all the necessary ADA accessible features, including the ramps for the sidewalk, and then the ramp onto the sidewalk, and then a reserved spot that'll satisfy a handicapped van. So in conclusion, we just thank you so much for coming to our SURF presentation to learn about Gleasman and Guthrie Engineering and the Lewis and Clark County Public Works Administrative Building parking lot. Thank you so much.